Most people think running an AI model means paying for OpenAI, ChatGPT, or Claude and sending your data to the cloud and hoping for the best. What if I told you your Windows laptop is powerful enough to run real LLM completely offline for zero cost? And once it is running, you can wire it directly into your IoT sensor pipeline. Hi everyone, I'm Hariharnath and welcome to IoT Frontier. Today, we are diving deep into running an local LLM on Windows using Ollama and then using it in a real IoT workflow using professional and scalable approach. Since we are running everything locally on Windows, there is no physical connectivity today. So we are going to simulate some of the things that we want. The only software that we would need is Python. So you need to install Python, and another thing is Ollama. So you need to go to Ollama. So you can type ollama.com and here you can see, so based on your OS, this command will change and you can install using PowerShell or you can use download Ollama button. So this will give you a website where you can download the exe file. So if you click on it, it will download. So it will be around 1.8 GB. So I have already downloaded. So once it is downloaded, you can simply double click and click on install. So it is straightforward setup and it will take just less than 2 minutes. So while it is installing, we'll go to the website of Ollama and find the different models. So you can click on here, you can see Gemma 4, which was recently launched. So it was updated yesterday. So you can find out different models that you want to run. So you can check the size of them as well. For example, Gemma 4, you can click on it and you can see the size. So the Gemma 4 latest is 9.6 GB. So for that, what you need to do is you can check the CLI. So Ollama run Gemma 4. This is the command you have to run in your command prompt once the Ollama installed. So for the sake of this tutorial, I'll use a smaller one, that is Llama 3.2. So here you can see this is having only 2 GB. So I'll just copy this and I can run like this, Ollama run 3.2. Now the Ollama is installed, even web page of this Ollama is opened. So here on the right hand side you can see it is loading all the models that are available in the market or in your system. It will find out whether whichever local models you have. So now you can see it is loaded. So you can see what are the different models it is available. You can also type here Llama and you can see 3.2 I have already installed. That's why it is showing not to, the download button is missing. The other ones you can see, you can click on download, you can do it from here also, but I will suggest you can go to a command prompt and type Ollama run Llama 3.2 or any kind of model that you can find. So what it will do is it will pull the manifest, download, because I have already downloaded, it was 2 GB. So for the sake of this video, I have downloaded earlier and then you can see it is going to run. So now it is asking for sending a message. So I'll just ask a simple question. What is MQTT in one sentence? Let's see how fast it will take. Because this is just a 3 billion model, it will take some time, and based on the GPU and CPU that you have, it will take different timings. So it has given in one sentence what is the simplest meaning of MQTT. So I can simply close this by using Ctrl D. And now you can select here in the Ollama this 3.2 and 3.2 3 billion model. So both are similar. So I'll just select that. And here also you can type anything. Like for example, what is AI agent in one sentence? So you can use just like ChatGPT, that this UI will be available and you can simply get the values from your local LLM. So that is how simple you can set up local LLM. And now that we have set up this local LLM, we'll go through the next steps of making sure to create IoT agent. So I'll open the command prompt. So I'll create Ollama IoT demo as a folder and then navigate into it using cd command. And first I'll try to create a virtual environment because we are going to use Python, and we activate that virtual environment and we need to install a pip install request for REST API calls. So it has downloaded that. Next thing is we need to create two Python files. One is to simulate the temperature sensor readings, because we are not using any physical sensor in this tutorial. We'll be simulating some of the sensors. So I'll simply use code sensor_sim.py so that it will open VS Code. And here you can see I'll just paste a simple code. So this code is nothing but it tries to simulate a temperature and humidity values like DHT11 or 22. And here you can see it is simply sending a random values of temperature and humidity and also location like machine room unit 3 and returning in this format. So I'll simply save this, and now I'll try to create another Python file which is for creating an agent. This takes the reading from simulated temperature sensors and build a prompt, and also queries Ollama with its LLM and gets an AI response whether the values that we are getting in the sensor are in the range of our threshold or not. So AI will respond and analyze that. So now what I can do is I can use code for opening in the VS Code. So this is IoT LLM agent.py. So this is the code that I have pasted. So this code will try to import some of the requests for communicating with Ollama, and then we can see we are giving some configurations from where the Ollama has to be queried and what is the model name that we want to use and what are the different thresholds. For example, in our IoT or industrial IoT system, for example, we can say 60 degrees is the warning temperature and 80 is a critical and humidity of 80 is also a warning. So based on this, the AI will respond correspondingly. So first we are trying to build a prompt such that we are saying that you are an agent which is like industrial IoT monitoring assistant, and it has to read the sensors, and this agent has to provide short actionable report in just 2-3 sentences. So based on the values that we are going to send, it will simply understand and analyze and gives us the short summary. So here we are trying to give the prompt in such a way that these are the values you will get in this format, and you need to respond with the what is the status, whether it is normal, warning, critical, and what action it has to take by the operator, and is there any kind of root cause if the readings are abnormal. So we are making sure that it is concise and professional to be easy to read. And then we query Ollama. So we just ask the model with this prompt, and what is the results that we get. This is the library to get the response using APIs. And finally we run the agent, and in the run agent we are trying to get the sensor reading, we build the prompt, and then query. So this is the sequence we are going to do, and simply I'll save this. So there was some indentation error, so I tried to fix that. So once we have done this LLM agent, we have to simply run this agent file, because this sensor sim is a module that we are using here, so you don't have to run it separately. So I'll go to command prompt and type Python IoT LLM agent.py. So here you can see sensor reading is received. So this is the random, and humidity is 88 and it is above 80. So we'll see what it shows. So overall LLM status is normal. The operator does not need to take immediate action, and these are in normal ranges, but one likely root cause of high humidity reading could be malfunction of air vent or insufficient ventilation in the machine room. So it is trying to find out the root cause as well, and you need to monitor the situation. So this kind of helpful information the LLM is giving. So I'll try to run again. We'll see what kind of information now we'll get. So now we can see temperature is 65, humidity is 66, and it is now showing as warning. So it is saying that operator should check the machine's cooling system to ensure adequate airflow and inspect for any blockages. And the root cause could be malfunctioning or clogged air filter. So it is trying to give different answer. Now we'll try again and we'll see. Temperature is high, humidity is low. So it is saying again warning, and we need to check the air filter kind of thing. And there you have it. a fully local LLM running on your Windows machine, analyzing real IoT sensor data with zero cloud dependency, zero cost, and zero data leakage. This is just the beginning. In the next video, we'll replace this simulated sensor with a real ESP32 publishing over MQTT, and the LLM will respond to live readings in a loop, and that too completely offline and completely local. If you want me to build that next view, drop the word ESP32 in the comments below. If I see enough of you asking for it, I'll make it happen. If you found this video informative, please subscribe and hit the bell icon. If you want to learn IoT from scratch, check out my course on Udemy. Thank you for watching, and I'll see you in another interesting video.